Hey friends, welcome to the YouTube channel all about electronics. So in this video, we will learn about the different IC packages that are commonly used in the electronics. So if you see these IC packages, then that is basically a protective case around the integrated circuit. So this protective case protects the chip from the dust, moisture and the physical damage. And the second and one of the most important thing is that it connects the chip to the outside world using either pins, leads or the bumps. And the third thing is that this IC package removes the heat from the IC whenever it is in the working condition. So in the electronic industry, different types of IC packages are used like the DIP, SOIC, QFP and the BGA. And looking at all these different packages, the first question that arises in our mind is like, why these different IC packages exist? And the reason is that each package is meant for the different application and the needs. So depending on the required performance and the application, the different IC packages are used. Similarly, in some application where the size and the cost is a constraint, accordingly the different packages are used. Likewise, depending on the required thermal management and the required output pins, the different packages are selected for the different applications. So in this video, we will learn about the commonly used packages in detail, and we will also see that in what type of application these different types of IC packages are preferred. So first, let us start with the DIP package. So this DIP means the dual inline package. So if you see this DIP package, that it is the through-hole package. So in this through-hole package, the leads extend out from the bottom of the package and they are designed to go through the holes that is drilled in the PCB. So nowadays, many ICs are not supporting this DIP package, but this IC package is still used in some legacy applications and commonly it is used for the fast prototyping. Specifically, when we want to do the fast prototyping using the breadboard. Moreover, this package is also used in the education as well as the training kits. Because in this IC package, using the readily available sockets, it is possible to swap the ICs. Moreover, this package is also preferred in the low-cost application. So this IC package supports the pin count in the range of 6 to 64. That means minimum 6 pin and the maximum 64 pin ICs are available in this package. And the different op-amps, microcontroller and the logic ICs are still available in this DIP package. Now the main disadvantage of this DIP package is that the overall footprint of the package is larger than the other packages. And here, as the pins are larger and longer, so the lead inductance is also higher. And because of that, the ICs that is available in this DIP package are not suitable for the high-speed application. And not only that, to use this package with the PCBs, we also need to make the holes in the PCBs. So these are the few disadvantages of the DIP package. So similar to the DIP package, we also have the SIP package, which is known as the single inline package. So in case of the DIP package, we have seen that the pins are arranged in the two rows. So in this SIP package, the pins are arranged in the single row. So this package is used very less nowadays, but still it is used in some resistive or the capacitive networks, as well as it is also used in some DC to DC converters. And if you see the early memory modules, then they were also using this SIP package. So similar to the DIP package, this package is also through-hole package. And apart from this SIP and the DIP, there is another package which is also through-hole package, that is the pin grid array package. So as its name suggests, in this package, the pins of the component are arranged in a grid-like pattern on the bottom side of the package. So in this package, as most of the bottom part of the package is used for the pin, so this package provides the much more pin contacts compared to the DIP and the SIP package. And mainly, this package is used with the sockets, so that the chip can be easily inserted, removed or upgraded without the soldering. So this package is typically used for some microprocessor CPUs as well as for some DSPs and the FPGAs where the easy replacement is required during the development as well as the deployment. So you will find this BGA package in some old generation Intel as well as the AMD CPUs. And in fact, some current generation Ryzen CPUs are also using this BGA package. For example, the AMD's Ryzen 5000 series CPUs are also using this BGA package. And this is the photo of the compatible socket. So the clear advantage of this BGA package is that it offers the easy installation, replacement as well as the upgradation of the chip via socket. Moreover, since the BGA package is also using the through-hole packet technology, so when the chip is inserted into the socket, then that provides the good mechanical strength. But the only disadvantage of this package is that the alignment is very critical, because during the insertion or the removal, the pins can bend or break, and therefore it requires the careful alignment. So as we have seen, this DIP, SIP and the PGA are the example of the through-hole packages. And similar to these packages, most of the TO packages or the variant of the TO packages are also available in the through-hole packages. So let us also briefly talk about this TO package. So here, this TO package refers to the transistor outline package. So this package is mainly used for the discrete components. So of course, although its name suggests that it is only meant for the transistors, but actually it is used for all the discrete components like the BJT MOSFETs, rectifiers and the diodes, as well as the voltage regulators and the power ICs. So there are different TO package variants, and each variant is used for the special purpose. For example, this TO247 is meant for the high power MOSFETs and the IGBT. Likewise, this TO3 is the metal can package, and it is mainly used for the very high power transistors. Similarly, this TO92 is the 3-pin package, and it is mainly used for the low power transistors, sensors as well as the regulators. And likewise, this TO220 package is mainly used for the voltage regulators like the 7805 and the 7815. So as I said earlier, most of the TO package variants are available in the through-hole package. But there are some variants of the TO package that are also available in the surface mount package. So as we have seen so far, most of the through-hole packages like the DIP, SIP or even TO packages have the larger footprint, and therefore they are not suitable for the compact designs. Moreover, as I said earlier, these through-hole packages also requires the drilling in the PCB, and that's why they are not suitable for the automation based assembly. So in applications where the overall small footprint is required or where the automation based component assembly is required, in such case the surface mount packages are used. So now let us see the different types of surface mount packages. So as its name suggests, the surface mount packages are mounted directly on the surface of the PCB. And compared to the through-hole packages, the surface mount packages allows much more compact design. Moreover, as the components are mounted on the surface of the PCB, so these packages are also suitable for the automated component assembly and the manufacturing. So there are different types of surface mount packages like the SOIC or the SOP, QFP, QFN and the BGA. So in this video, we will learn about all these packages. But first of all, let us start with the SOIC and the SOP package. So here, the SOP refers to the small outline package, and similarly, the SOIC refers to the small outline integrated circuit. So here, the term SOIC and the SOP is often used interchangeably, but both packages refers to the small outline package. And these packages occupies 30 or 40% less space compared to the DIP packages. And that is the main reason they have replaced the DIP packages in the modern PCBs. So both these packages are the two-sided packages, meaning that the leads are arranged in a row on the both sides of the package. And these packages are using the Gullwing kind of leads. So in these packages, if we see the pin count, then it ranges from the 8 pin to the 64 pin. That means the ICs with the 6 pin to the 64 pins are available in these packages. So in these packages, of course the lead length is little shorter than the through-hole packages, but still it is of the moderate length. And because of that, these packages have the higher inductance. And that is why they are not suitable for the high-speed application. So because of its smaller footprint, the conventional ICs like the logic ICs, op-amps and the other general purpose ICs which were earlier available in the DIP package are now mostly available in this SOIC and the SOP packages. So earlier I have said that the term SOIC and the SOP are often used interchangeably in the electronic industry. But there is a minor difference between this SOIC and the SOP package. So basically, this SOP is the broader category of the small outline package. While if you see the SOIC, then it is a specific type within the small outline package. So as we have seen, both these IC packages are using the Gullwing kind of lead. But the main difference between these two packages is in terms of the width of the package as well as the lead pitch. So typically, these SOP packages are available in the different versions like the SSOP, TSOP and the TSSOP. So for example, this SSOP refers to the shrinked version of the standard SOP package. So in this version, the body width has been reduced compared to the standard package. Likewise, there is another version called the TSOP, that is the thinner version of the standard SOP package. So in this package, the height of the package is smaller compared to the standard SOP package. And likewise, there is another version called the TSSOP, that is the thinner and the shrink version of the standard SOP package. On the other hand, in the SOIC package, we have only two versions, that is narrow and the wide SOIC package. So if you want to know more about it, then you can pause the video and check this table for the more information. So similar to the SOIC and the SOP package, the another surface mount package is the SOT package. So basically, it is the surface mount version of the TO package. So earlier we have seen that in TO package, most of the variants are the through-hole package. But this SOT is the surface mount version of the TO packages that is available in the smaller footprint. And similar to the TO package, this package is mainly used for the discrete components. So in this SOT package, the 3-pin package is the most common. But typically, the pin count in this package can vary from the 3-pin to the 8-pin. So similar to the SOIC and the SOP package, these SOT package ICs are also using the Gullwing kind of leads. And in some variants of this SOT package, there is also additional thermal pad for the better thermal management. So similar to the different TO packages, the different SOT package exist for the different needs. For example, the SOT 523 package is mainly used for the ultra miniature devices. Likewise, the SOT 323 is mainly used for the small signal transistors and the diodes. Similarly, the SOT 23 package is mainly used for the general purpose transistors, regulators and the amplifiers. And likewise, the SOT 89 and the 223 packages are used for the power transistors and the voltage regulators. And likewise, if you see the SOT 143 package, then mainly it is used for the dual transistors or the matched pairs. So in this way, the different SOT packages are used for the different needs. So as I said earlier, this package is typically used for the discrete semiconductor components like the diode, MOSFET and the transistors. But apart from that, it is also used for the other components like the voltage regulators, comparators, opto-isolators and the other similar devices. And as you know, all these different components are used in all sort of applications, like from the consumer electronics to the signal processing. And similarly, it is also used in many industrial controls. So similarly, now let us see the next type of surface mount package, that is the QFP. So here, this QFP refers to the quad flat package. So in case of the SOP or the SOIC, we have seen that the leads are arranged in the two rows on the two sides of the package. But this QFP is the four-sided package. That means in this package, the leads are there on the all four sides of the package. And similar to the SOIC package, this package is also using the gullwing kind of leads. So for this package, the pin count ranges from the 64 pins to the 256 pins. And this package is typically used for the microcontrollers, DSPs as well as the ASICs. Now when there is a space constraint, then in such applications, the thinner version of this package is also used. So this version is known as the TQFP, that is the thin QFP package. So this version has a lesser height compared to the standard version. So similar to the SOIC package, as this package is also using the gullwing kind of leads. So due to the relatively higher lead lengths, the lead inductance is also higher. And because of that, this package is not suitable for the very high frequency applications. Moreover, in higher pin count QFP packages, as the leads are very near to each other, so due to that, the soldering complexity increases. So these are the few disadvantages of this package. So similar to the QFP package, there is also another package that is known as the QFN. And this QFN package is also surface mount package. So here, this QFN stands for the quad flat no lead package. So as its name suggests, this package does not have any leads, but it has a flat contact pads on all four sides. So this package is available in the square as well as the rectangular form. So in this package, the semiconductor chip sits on the center, and through the wire bonds, the connections are provided on the flat contact pads. And then these contact pads are soldered on the PCB. So this package is available in the very small form factor. And if you see the pin count for this package, then it ranges from the 8 pin to the 100 pin. Now the advantage of this package is that it is very compact and the low profile. Moreover, on the bottom side of this package, in the center there is a metal pad. And this pad directly comes in the contact with the PCB. And due to that, it helps in dissipating the heat efficiently. So that is the reason this package provides the excellent heat dissipation. Moreover, as this package does not have any leads, so the contact pads on this package offers the lower inductance. And due to that, this package is ideal for the high frequency and the high speed applications. Moreover, being the surface mount package, this package is also suitable for the automatic assembling of the components. So these are the few advantages of this QFN package. Now the only difficulty with this package is that as the solder joints are under the package, so through the visual inspection, we cannot see the soldering. And therefore, to check whether the soldering is happened correctly or not, we need the X-ray inspection. So if you see this QFN package, then it is used in the various applications like in the smartphone and wireless modules for the various components. Similarly, many microcontrollers are also available in this package. Likewise, many power management ICs and many RF circuit components are also available in this package. So similar to the QFN package, we also have the DFN package, which is known as the dual flat no lead package. So in case of the QFN package, we have seen that the package had the pads on all four sides. So similarly, this DFN package has the contact pads only on the two sides. So if you see the pin count or the number of contact points for this package, then it is in the range of 3 to 32. And this DFN package has even smaller footprint compared to the QFN package. So these are the different applications where these DFN packages are used. So this DFN and the QFN are the no lead packages which are available in the small form factor. So similarly, let us see another surface mount package which is nowadays commonly used when the high pin density is required in a compact form factor. So this package is known as the BGA package, that is the ball grid array package. So if you see this BGA package, then it is evolved from the pin grid array package. So this package has replaced the protruding pins of the PGA package by the solder balls underneath the package. And as you can see in this image, these solder balls are arranged in the grid-like pattern. So that is why this package is known as the ball grid array. So the design of this package allows the entire bottom surface to be used for the connections rather than the perimeter. And therefore, it allows the much higher pin densities. So this package can accommodate more I/O connections in a smaller footprint compared to the perimeter only packages like the QFP and the DIP. So in this package, the internal traces from the dies to the solder balls are shorter than the other peripheral packages, and therefore it has the lower contact inductance and the resistance. So that is why this package is suitable for the very high frequency and the high speed applications. Moreover, here as the entire bottom surface is contributing in the heat transfer, so this package provides the better heat dissipation. Now the only downside of this package is that as the solder balls are beneath the package, so the visual inspection of the soldered connection is not possible. And therefore, for the inspection it requires the special X-ray equipment. So this BGA package is typically used for the components which requires the higher pin count in the small form factor, like the microprocessors, GPUs, digital signal processor, as well as the high performance microcontrollers, RAM modules and the FPGAs. And as you know, these components are commonly used in the consumer electronics and many high-end telecommunication and the signal processing equipments. So that is all regarding the BGA package. So if I just summarize, then we have seen the broadly two types of IC packages. That is a through-hole package and the surface mount package. And in that also, we have seen the different variants. So I hope in this video, you understood about the different IC packages and you also learn why different IC packages exist and in what type of application certain IC packages are used. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.